Bismillahirrahmanirrahim. Now we are starting the third session of lecture number 3. And if you remember, I finished with few examples. We discussed one way or the other we can easily apply the double integral, whether we are solving with respect to x first or with respect to y first. So now in the start I am writing few examples for your practice. So you have to apply all those things which we discussed in the lectures of part 6a and 6b. So now I am writing few examples, and then inshallah I will conclude that session with few important tips. So these are the practice problems to follow in the same order. So now I am writing few examples for you. So example number 1 is 0 to 2, and I will discuss these examples as well. 0 to x square e to the power y over x dy dx. Sorry. And I am mentioning the answers here as well. In the bracket you will find the answer of that question. Then example number 2, 0 to a and 0 to under root ay, and then xy dx dy, and the answer is a power 4 upon 6. Then another example is number 3. In number 3 we have 0 to a and 0 to under root a square minus y square, and we have only dx dy, and the answer is pi a square upon 4. Then number 4, we have 0 to 1 and y square to y, and then we have 1 plus x y square dx dy is, and the answer is 41 upon 240. So now I am discussing all those examples first, and then I will write few more examples. If you remember, I started with giving you the idea that when we want to apply double integral, then there are three possibilities there. Number 1, the hint is given there that you need to integrate with respect to x first. It is possible that hint is given that you need to integrate with respect to y first, or finally there is no hint there. You need to decide yourself that whether it is appropriate to integrate with respect to x first or y first. Generally, in those cases, in more than 90% cases, it is possible to solve the question in both ways, as I discussed in 6a and 6b part of the lectures, and I suggest you in those parts that I am doing one way and you can try the other way out as well. It will give you some practice as well. So here I write first 4 examples in which either the hint is given doing with respect to x first or with respect to y first. So how we can find that? If the limits are given in terms of x, it means you need to integrate with respect to y first. Just like in question number 1 and in question number, in question number 1, because the limits are given in terms of y, so we in terms of x, so we will integrate with respect to y first. And then in 2, 3 and 4, the limits are given in terms of y, and this an indication that we need to integrate with respect to x first. This is the one way of double integrals. Now I will write few more examples on the other part. Then in those cases we need to decide that which is appropriate for us, whether with respect integrating with respect to x first or with respect to y first. So now I am writing few examples of that particular order. So let's say I am writing that evaluate the following double integrals. Evaluate the following double integrals. Number 5, double integral over the region A. The term is 5 minus 2x minus y, where A is the region given by the curves y equal to 0, x plus 2y equal to 3, and x equal to y square. So here what is required? We will draw the figure first. We will draw the figure in xy plane by drawing these y equal to 0, x plus 2y equal to 3 and x equal to y square, and then we will figure out the area which is bounded by all three curves and try to sort out that as per our requirement whether it is appropriate to integrate with respect to x first or with respect to y first. And the answer is 217 over 60. Similarly, example number 6. Now the integral of xy, where A is the area enclosed by the curves x square plus y square minus 2x equal to 0, y square equal to 2x, and y equal to x. Almost identical kind of question, and the answer is 7 over 12. Then another question, this is number 7. This is double integral over the region R. We have x square dx dy, where R is the two-dimensional region bounded by the curves x equal to y and y equal to x square. Then finally question number 8. We have under root 4x square minus y square dx dy, and the answer is 1 over 20 dx dy, where A is the triangle given by the lines y equal to 0, y equal to x, and x equal to 1. And the answer is 1 upon 3 pi by 3 plus under root 3 by 2. So here I given you few examples just to give you some practice questions, that whatever we learned in 6a and 6b, you need to apply those things in these examples. So I divided these examples in two parts. In 1 to 4, there is a hint given that whether you need to integrate with respect to x first, or integrate with respect to x first, or with respect to y first. And in this segment, I am giving you the double integrals in such a way that you have to draw these figures to decide that which area is appropriate to integrate, and then solve accordingly. So you have to find the way out, that how it will be concluded. So now I am going to solve one more example to establish this idea that how we can do this. So now I have solved one example to show you that why changing the order of integration is so important. If we are able to solve the question either with respect to integrating x first or with respect to y first, sometimes it becomes very, very important to decide that which is well appropriate for us. That is why when in questions you have the choice to integrate with respect to x first or with respect to y first, it becomes very crucial for us. So just to strengthen that point, I like to share an example with you to show you that how important it is to have the grip on the idea of changing the order of integration. E to the power minus y upon y dy dx. So let's say I have the question in this format. So if you look at the limits, it will suggest you that it is appropriate to integrate with respect to y first, because the limits are given in x. So as I told you previously, that it is always a hint that you need to integrate with respect to which variable first. But now the problem is that if I need to integrate with respect to y first, then it is not possible for me to integrate this term, because even if I apply the u into v formula, then it is difficult for me to compact the question or compact the solution in 2, 3, 4, 5 steps, because it will become expanded and expanded and expanded as I will apply the u into v formula of integration again and again. So this will not appropriate for me, even though the hint is given, but it will be difficult or almost impossible for me to integrate in this order. So if I switch the order, say if I apply the integration with respect to x first and then with respect to y, then what will happen? But for that I need to find out that what will be the limits in that case. It is important, and this becomes easier once I draw the figure. That is why in previous examples I focused on drawing the figure. So once you have the figure, then it will become very easier for us to conclude that which which variable will be appropriate to apply first. So here, if you look at this carefully, if I find this that x and y is this thing, so what is the area and which area will be appropriate to loop? Here the limits are given, these are limits of x equal to 0 to infinity. So this is the line x equal to 0 to infinity, so on. I am trying to figure out the drawing with the help of these limits. Here this limit is given with the value of y. So here y is equal to x. So if I want to try, then this is y equal to x line. And the upper limit is again infinity. So it means what is required is we are discussing the whole area. This is the whole area till infinity. This is the whole area. This is the whole area which we are trying to calculate. So it means if I switch the order of integration, so then it will be 0 to infinity and 0 to y e power minus y upon y dx dy. Because the values of x are from 0 to y. Here x equal to y, here x equal to 0. So now I have the limits of x. And now I can integrate this term easily, because with respect to x, this whole term is a constant. So when I integrated this term, I got e power minus y upon y into x. And substituting the limits 0 to y dy. Straightforward integration with respect to x, which was not possible with respect to y. Now it becomes 0 to infinity e power minus y upon y, substituting the upper limit y minus lower limit 0 dy. It means this is equal to 0 to infinity e power minus y dy, because y cancels with y. And now you look at this integral, it is very straightforward to integrate. So now I can easily integrate e power minus y over minus 1 and substituting the limit 0 to infinity. So it means this is equal to minus 1 upon e power y and 0 to infinity. So this is equal to minus 1 upon e power infinity minus 1 upon e power 0. Sorry, plus 1 upon e power 0. So it means 1 upon e power infinity is infinity. So 1 upon infinity is 0, e power 0 1. So final answer is 1. So look at this example and see that if I try with respect to y first, then this integral will become almost impossible for me to integrate. So it is very important for us to understand that sometimes the change of order of integration becomes much more important. So that is why I am emphasizing in all these examples that please try to understand that which variable is more appropriate to integrate with respect to x first or with respect to y first, and for that we only need the change in the limits. So if you draw the figure, then it will become much more easier for you to understand that what will be the limits of x and what will be the limits of y in case we are trying to change the order. So this is the example to show you the importance of change of order of integration. And now I am ending this third part of lecture number 3 on this example, and I hope that you will try to solve all these examples which I given you in this segment with answers as well to understand this. Inshallah, in the start of the 7th lecture, we will continue with the topic of multiple integrals, but this time we will start inshallah with three integrals at a time, x, y and z. The questions in which three variables are involved to integrate, and this will be the topic we will start with the new lecture of 7 inshallah in next week. So it's goodbye from now. Thank you for your kind patience.